Chemistry Chapter 21 Theory Video 4. Now we are going to look at calculating Ka for a weak acid. So earlier we discussed about how to calculate the acid dissociation constant for strong acids. Now we are going to look at Ka for weak acids. So in the earlier situation, as you can see here, the equilibrium expression was H plus CH3COO minus divided by CH3COOH, or the general formula Ka equals H plus A minus over HA concentrations. So in that particular situation, we took the concentration of the acid to be equal to the concentration of the H plus ions. But now for a weak acid there is a problem, because we can't actually take the H plus ion to be equal to H plus ion concentration to be equal to the concentration of the acid, because not all the ions would dissociate. So to calculate Ka of weak acid, we need to find we need two things. That is, the first thing is the concentration of the acid, and the second one is the pH of the solution. The concentration of the acid as well as the pH of the solution is needed. So now if you take a general equation for an acid dissociation, it is going to be HA aqueous dissociating into H plus and A minus. So when HA, that is a monobasic acid, then when it dissociates, you know that it is one H plus ion and one A minus ion would be produced. So then we, in this particular situation, we have disregarded the H plus ions that we have got from water. So H plus ion concentration is equal to A minus ion equation. So from that we can write Ka H plus over A minus divided by HA concentrations. Then Ka can be written as H plus ion concentration over HA concentration. So we assume there are two assumptions that we make. We ignore the concentration of hydrogen ions produced by ionization of water, because the ionic product is actually very low when compared to the H plus ion concentrations of weak acids. Then another a little bit of confusing assumption that we have made is that the ionization of the weak acid is so small, so that means the undissociated HA molecules present at equilibrium approximately is same as that of the original acid. So this is some some assumption that we make. So that is a little bit confusing, but let's go through the example and see how it is going to make it easier for us to calculate H plus ion concentrations or the strengths or the Ka values of acids in our A-level level. Now they are asking us to calculate the value of Ka for methanoic acid. You know that methanoic acid is a weak acid. It has the solution has 0.010 mole per cubic decimeter methanoic acid, and it has a pH of 2.90. So first of all, what we need to do is we have to convert that pH to H plus ion concentration. We know the equation H plus ion concentration is equal to negative logarithm of the H plus ion concentration to the base 10. So then from this way we convert that into concentration of H plus ions, that is 1.26 into 10 to the power minus 3 mole per cubic decimeter. Then we write the equilibrium expression, that is H plus ion squared over H plus into A minus 1, which is going to be the same, divided by HA. So here what we do is the concentration of H plus ions is 1.26 into 10 to the power minus 3. We square that, or A minus is also the same, and divided by HA concentration has been given 0.010. Then when we divide it, we get Ka to be 1.59 into 10 to the power minus 4 mole per cubic decimeter. I hope that made sense. If it has made sense, please do question number 6. Now write down, to calculate Ka for a weak acid, we require the concentration of the acid and the pH of the solution within brackets, right, to find the H plus ion concentration in the acid. Because H plus ion concentration is equal to A minus ion concentration for HA, we get the equation Ka equals H plus ion concentration squared divided by HA concentration. Leave a line and write. Two assumptions are made when reaching this. Number one, we ignore the concentration of H plus from water because its ionic product is very less compared to water, compared to weak acids. Number two, we assume that the ionization of the weak acid is so small that at equilibrium the undissociated HA molecules would be the same as that of the original acid. Right. If you understood, please do question number 6. After doing the question, let's move on to the pH of a weak acid. So if you know the concentration of the acid and if you know the Ka of the acid, so then to find the Ka, we know that concentration of the acid as well as the pH would be known, would be required. So now we are turning the pH is what we are going to figure out. We need the concentration of the acid as well as the Ka of the acid. Again, we make the same assumptions and we calculate the pH based on these values. First of all, we use the Ka to find out the pH of the ethanoic acid here. In this particular situation, they have given calculate the pH of 0.1 mole per cubic decimeter ethanoic acid. Ka has been given. So we write the equilibrium expression. We know that Ka is equal to H plus ion concentration squared divided by CH3 COOH concentration. Then we know that Ka is 1.74 into 10 to the power minus 5. We know the acid concentration. From that we can get the H plus ion concentration. H plus ion concentration is 1.32 10 to the power minus 3. Using that we calculate the pH. pH is negative logarithm to the base 10 of H plus ion concentration. I hope that made sense as well. Do question number 7, but before that write down this note. To calculate the pH of a weak acid, we require the concentration of the acid as well as the Ka of the acid. Right. If you want, you can write down this worked example to make it clearer for you if you have any doubts. If not, please move on to question number 7. We will discuss buffer solutions in our next video.